right, hello and welcome back. Now we're going to be talking about dilutions. So either you just came from the molarity video or you just need to watch dilutions. Either way, we're going to go ahead and get started. So whenever we talk about dilution, dilution is the process of making a solution. Anyone want to take a stab at it? Yeah, perfect. Less concentrated. Okay. Almost exclusively, we make a solution diluted by adding more solvent. Okay. So looking at our two pictures here, which one of these, A or B, is going to be more concentrated? A. And which one's more dilute? B. Okay. So it's the same. If you count up the dots, it's going to be the same number of spheres in both of them. But remember, concentration is per defined space. There's less space here, so there's more stuff per space, so this one's more concentrated. Okay. You can also kind of think of this as like making powdered drinks, right? So the more powder you add, the more concentrated it's going to be. If you end up making it too concentrated, you can add in some liquid, some water, to dilute it down. Yeah? That's just what's happening here. All right, so we usually use molarity in dilution problems, as that's the way that we talk about and express concentration in chemistry. So whenever we add more solvent, what are we doing to the concentration? Say it louder. Decreasing. We decrease the concentration of the solution, which does what to the molarity? Decreases our molarity. And so it makes our solution more what? Diluted. Wonderful. Okay. The formula that you use to calculate molarity is V1M1 equals V2M2, or we refer to this as the Voom-Voom equation. Okay? VM, we call it Voom-Voom. Now, something really important I want to point out with our Voom-Voom equation, okay? Keep in mind, Voom-Voom is now 4 variables. Molarity equation was 3. So if you're given 3 numbers, it kind of makes sense that you probably want to use your Voom-Voom equation and solve for the missing variable. If you're only given 2 numbers, you want to use molarity because you don't have enough information to solve for 1 variable, okay? Also, Voom-Voom is for dilutions. So that means that we are not changing our substance. All we're doing is adding more solvent, okay? So if it ever asks us to compare amounts for one substance versus a different substance, you do not use Voom-Voom. You'll use Stoich, which we'll go to later. Okay, so looking at this example, what is the molarity of a solution of ammonium chloride prepared by diluting 50 milliliters of a 3.79 molar ammonium chloride solution to a final volume of 2 liters. It's simple algebra, okay? The hardest part of this is just making sure that you pair up the right numbers. So you pair up the volume and its corresponding molarity, okay? So I'll give you a hint. Anytime it says of A, those are going to be paired together, okay? So let's go through and label our variables. What are we, so 50 milliliters, what would we call this? Yeah, let's say V1. What would we call 3.79 molar? M1. Final volume 2 liters, what would this be? V2. So what is the molarity we're solving for? M2. Okay? Now, I'm not looking for you in your problem to go through and label these, okay? You don't have to. If you want to, awesome, but you do not have to, okay? I just want to make sure that you know that you have to pair them correctly. If you pair 50 milliliters with the molarity you're looking for. You will be wrong. Okay? Now, so we're going to use our voom voom. Sometimes I feel like I'm talking to a baby whenever I say voom voom. So we're using our voom voom solution, our equation, okay? Can we go ahead and plug these numbers in as they're written? No. Why not? You've got liters and milliliters, okay? For voom voom, it doesn't matter which one you use. So you can either convert both of them to liters or convert both of them to milliliters. It doesn't matter because you've got volume on each side, okay? Now if it asks you to solve for volume and you want to solve for liters but your other one is given to you in milliliters, it probably makes sense to convert this to liters, okay? But if you're not solving for volume, as long as the two units are the same, it doesn't matter which one you use, okay? So you could convert 50 milliliters to liters, or you can convert 2 liters to milliliters. I'm going to go ahead and just convert this first one, milliliters to liters, but it does not matter. So if we go and plug this in, we'd end up with 0.05 liters times 3.79 molar equals 2 liters M2. And then at this point, it's just simple algebra. You are solving for M2. You're solving for your variable. So you would take both sides and divide it by 2. So your final answer, your final molarity is what? Good. With sig figs, it'll be 0.0948. But yes, perfect. 0.0948 molar. Questions? Okay, cool. So, this next one, it says, oh, you can't see it, okay. Oh, hello. A 1 liter, 3.8 molar solution of iron sulfate has 7.0 liters of water poured into it. What is the molarity of the new diluted solution? Okay, so it talks about dilution, so what formula are we going to use? Voom voom. Okay. What is our volume 1 going to be? 1 liter. What is our M1 going to be? What is it? 3.8 molar. Are we solving for V2 or M2? M2. What is our V2?
8, because you have to add the original liter.
So it is 8 liters. So this says 7 liters of water poured into it. So that means we've got our original 1 liter and we've poured in an additional 7 liters. So our new total final volume is 8 liters. And then M2. So you need to make sure that you read your question carefully. We are going to try and trick you like this. Okay. All right, so whenever you solve for M2, what is your answer? 0.48 molar with correct sig figs. Questions? All right, those of you watching the video, go ahead and solve this, okay? And then come back and I will talk about how we are going to prepare it. So solve for what it's asking, and then we'll talk about the rest together. All right, so you should have gotten to this point. I do want to point out that here I labeled it as V1 because technically, since we're starting with a stock solution and we're figuring out the volume of the stock solution, this would be our volume 1 and our M1. However, if you want to go ahead and label these as this is V2, and as long as this is M2, it doesn't matter. So all that matters is you match up your numbers correctly. So if this is V2, this is M2. If this is V1, this is M1. Okay? So in this case, I labeled it V1 because technically that's what it would be, but if you labeled it V2, that's totally fine. So what was our answer? What did we find?
166.67.
So with sig figs, 167 milliliters. So that's our volume of our original solution. So then it asks, how would you prepare 500 milliliters of a 2 molar hydrochloric solution from 167 milliliters of 6 molar? I don't need you to do step by step by step. I just need to, so we're assuming that we've got the right volumetric, okay? We've got all of that kind of stuff. What do we need to do to get the correct concentration and get the correct volume? Anyone have a guess? Add what?
400, and we said it was 33.
You're off by 100.
3.
So, we're actually going to add 333 milliliters of water to the 6 molar stock solution. Or if you want to say to the 167 milliliter 6 molar stock solution, however you want to say that, okay? Because the solution that you are making is 500 milliliters. So that means your final volume of your solution is 500 milliliters. You are starting with your stock solution. So stock solution is actually what we order from the chemical companies. They come in somewhat higher concentration, higher molarities that then we dilute down for y'all to use in your labs. So a stock solution is what we've got in the back in our chemical room. Okay, so that's what you're starting with. Then you need to make 500 milliliters out of this. So you calculated how much of this you need, but we're not adding 500 milliliters of water to our 167. 500 is our total solution, so we would just have to do 500 minus 167. And know that the difference is 333. So that's how much water we have to add to get our 500 milliliters of our 2 molar solution. Yes? Does that make sense? Yeah. So it asks how would you prepare? So I'm asking you to make one, so I'm basically saying what would you need to do? And here I'm not making you run out every single step, okay? I just want you to know that you would start with this amount of your stock and then add water to get to your final volume. Okay? All right. Questions? All right. That is it for dilution. So if you need to learn about reaction stoic, look at the next video. Otherwise, that's it. Have a great day.